Hi, it's Matt, and in this video we're going to talk about how to implicitly find the second derivative. So, just a few notes about when we implicitly find the first derivative. I am going to assume that you're already familiar with this. If not, I suggest you watch my video on implicitly finding the first derivative before watching this video. So just some notes. So after finding the first derivative, in general, we're going to obtain dy dx is equal to f of xy. So f of xy here is just the general expression that could contain x, could contain y, could contain both x and y, or it could even contain neither and be a constant. But what's important is that we have our differential on our left side, and then that's just equal to some equation with potentially x's and y's. So often also f of xy is going to be a fraction. However, that's not always the case, but usually it is. And just as with explicit differentiation, when we find the second derivative, we're just going to take the derivative of the first derivative. So now let's make a little bit more concrete the steps to find the second derivative. So to implicitly find the second derivative, we're first going to have to implicitly take the first derivative. And that will get us in the form dy dx is equal to f of xy. Again, we want to have it in this general form. Because then we could just differentiate the left-hand side, and without going into the nuance of things, when we differentiate dy dx, our first derivative, we're just going to get d squared y dx squared, our second derivative. And now we're going to differentiate the right-hand side, so that would be differentiating that f of xy. So again, we're going to differentiate the right-hand side using our standard derivative rules. And remember, we're going to need our rules for implicit differentiation. So if we differentiate something with a y, we're going to need a dy dx after it. And now, but when we do that, we're going to get that d squared y dx squared is going to be a function of x, y, and our first derivative. We don't want the first derivative there, so we're actually going to plug in the result for dy dx back into our equation. And I know right now that might not make sense why, but we'll see that in the examples. So now let's try our first example. So we're asked to find d squared y dx squared, our second derivative, given x squared plus y squared equals 9. So first, let's find dy dx. Let's find our first derivative. So we're given x squared plus y squared equals 9, and we want to find dy dx. So to do that, we're going to start by differentiating the left-hand side. So x squared, the derivative is 2x because of power rule. And then we'll again apply power rule to y squared and get 2y. However, again, since there's a y here, we know we need the dy dx afterwards. So that's good for the left-hand side. For the right-hand side, 9's a constant, and when we differentiate a constant, we get 0. So our right-hand side, the derivative is 0. Now that we have this equation, we just need to use algebra to find dy dx. So to do that, we're going to start by subtracting 2x from both sides, and that's going to give us 2y dy dx is equal to negative 2x. Lastly, we're going to divide by 2y on both sides. And when we do that, we're going to get dy dx is equal to negative 2x over 2y. Canceling the 2's gives us negative x over y. So this is our first derivative, and we see it's in the form we want, where we have dy dx on the left, and then a function of x and y on the right. So now that we have our first derivative, we need to find our second derivative. So to find our second derivative, I'm going to start by rewriting the first derivative. So dy dx is equal to negative x over y. And now we're going to differentiate both sides. Differentiating the left-hand side gives us our second derivative, d squared y dx squared. Now to differentiate the right side, we're going to need quotient rule. So we can recall that quotient rule says d dx of u divided by v, where u and v are functions, is going to be v du minus u dv over v squared. So in this case, u is our numerator, so u is negative x, and v is our denominator, which is y. So the derivative of u is the derivative of negative x, which is just negative 1. And then the derivative of v, or the y, is going to be dv is going to be equal to 1 times dy dx, where the dy dx comes from because there's a y. So now plugging into quotient rule gives us that our derivative will be y times negative 1, and then minus a negative x times dy dx. And then that's all going to be divided by y squared, because y is v. So now we just need to simplify this a little. So we get d squared y dx squared, and that's going to be equal to negative y plus x, because the negatives cancel. But now we're not going to write dy dx. Instead, we're going to plug in what we know our first derivative is, which is negative x over y. Then that's still over y squared. Continuing to simplify, when we get that our numerator becomes negative y minus x squared over y, and that's going to be over y squared. Now, we could leave our answer like this, but we want to simplify it a little bit more. So what I'm going to do is I'm going to rewrite our left term, instead of negative y, as negative y squared over y. And the reason is, when I do that, I could take our y's in the denominator and move them down to be with the y cubed. And when I do that, I get negative y squared minus x squared over y cubed. So this here is our final answer for the second derivative, negative y squared minus x squared over y cubed. Let's do a second example. So we're asked to find the second derivative implicitly, given ln of x squared plus ln of y is equal to e to the fifth. So first we need to get our first derivative, and to do that I'm going to write our equation. So ln of x squared plus ln of y is equal to e to the fifth. Now we're going to differentiate each side. So remember that the derivative, so d dx of ln of a function u is going to be equal to 1 over u du. So differentiating the left-hand side, we get 1 over x squared, because x squared is what's in the ln, and then times the derivative of x squared, which is 2x. For the second term, it's going to be 1 over y, since it's a y in the ln, and then times the derivative of y, which is just dy dx. And now, on our right-hand side, e to the fifth is just a constant, so when we differentiate it, we're going to get 0. So now we just need to solve for dy dx. So to do that, first I'm going to simplify our leftmost term to be 2 over x. So we get 2 over x plus 1 over y dy dx is equal to 0. We then can move the 2 over x to the other side to get 1 over y dy dx is equal to negative 2 over x. And finally, to isolate dy dx, we'll multiply both sides by y. And this gives us our first derivative found implicitly is dy dx is negative 2y over x. Now that we have that, we could find our second derivative. And to do that, I'm first going to rewrite our first derivative, dy dx, is equal to negative 2y over x. Differentiating the left-hand side gives us d squared y dx squared. And then to differentiate the right-hand side, we're again going to need quotient rule. So again, quotient rule says that d dx of a function u over a function v is going to be v du minus u dv over v squared. And u is our numerator, so u is negative 2y, and v is our denominator, which is x. Therefore, du is going to be negative 2, and since there's a y, that's negative 2 dy dx. And then v is x for the denominator, so we just get dv is equal to 1. So now plugging in, we get that v du is going to be x times negative 2 dy dx Then minus u dv is going to be minus a negative 2y times 1. And then over v squared is going to be over x squared. So this thing gives us d squared y dx squared is going to be equal to negative 2x dy dx. But instead of dy dx, I'm instead going to plug in what we found over here, negative 2y over x. And then our negatives cancel, and we get plus 2y for our second piece. And that's all over x squared. Notice, though, for the first term in our numerator, this x and this x cancels out. So we're left with d squared y dx squared is going to be equal to negative 2 times negative 2y, which is 4y plus 2y, all over x squared. So we find that our second derivative, d squared y dx squared, is just equal to 6y over x squared. And this here is our final answer. Now that we've worked out two together, here are two more problems for you to find on your own. So you're first going to find your first derivative, dy dx, and then you're going to go on to find the second derivative. The answer to these will appear in 5 seconds. Okay, so for the first part, for problem 1, you should have gotten your first derivative was negative x cubed over y cubed. And your second derivative was negative 3 times the quantity x to the 6th plus x squared y to the 4th, all over y to the 7th. Then for problem 2, you should have gotten your first derivative to be negative 4 minus 3y divided by 7 plus 3x. And then your second derivative was 6 times 4 plus 3y divided by 7 plus 3x squared. If you got these, great. If not, feel free to leave any questions you have in the comments below. Thank you so much for watching. Have a great day.